Hi guys, welcome to another installment of OpenDB Tutor. Today I'm going to take you to basically how to perform some session management and also how to basically monitor locks and latches inside in the system, and also I'm going to go into what events are and how basically those things affect the performance of the local of for the users who are basically just accessing the database. So these are the things that I'm going to cover today. Basically, I'm going to introduce you to what the logs, the latches, and the wait events are. I'm gonna basically go over what an Oracle log process is and basically its function inside of Oracle. And I'm also gonna cover session management. I'm gonna give you some real world examples of how to basically just assess a user experiencing really bad application performance. Basically, I'm just gonna I'm gonna resolve. And it's like an example of a contention that you would see in the real world. And then next, I'm going to go into what exactly are latches and how they're used in the software. And then I'm going to go into what the Oracle web interface is, and I'm going to give you a brief overview of what the parts are for the OWI. And then I'm also going to cover, I'm going to go basically into great details on what the web events are, and basically how that ties in with the session management that you be performing. And then I'm also going to cover the real-time transaction capturing. Basically, you're basically able to resolve database users concerns on the fly. So in introduction to logs, latches, and web events. So basically, inside of Oracle, you have three processes that are used to basically just manage the different access to different database objects. You have the logs, and you have the basically you have the locks, you have the latches, and then and again, so basically what they do is the locks and latches, they just restrict access to database objects from other users, from other sessions or server processes. And then you have wait events. So wait events basically are just basically the period of time that a server process or session has to wait to be able to access a database object. When another session is already already has an access. So it's just how long another session is just waiting for the other session to be done with the database object. And then I'm gonna and basically again, so as I've just told you, so it's just caused by the server processing sessions are going to be interchangeable throughout the tutorial. And basically it's just what you're doing is you just you have the server processes have to have access to the database object for resolvency, right? So again, all these different processes, the reason why they occur is to just to regulate this reading that has to take place inside of Oracle software. So basically, again, so it's server process. Basically, it's just a what it does is it's if you just remember just how transactions work inside of Oracle. The server process is basically what it does is it services the different user sessions. So basically, once you connect to Ogo, a server process is created for you. If you are in a dedicated server, server method or configuration. So basically, the server process is able to service your request. Basically, it's actually it's that one component that's responsible for basically accessing different objects to satisfy whatever your query demands are. So in terms of the database objects themselves, so basically, again, these are just what the these are just objects that the server process would have to go and access to be able to perform the reads. So you have a simple objects, and you also have compound objects. So basically, in terms of simple objects, you can think of like a redo log buffer, a buffer cache, a library cache. Those are all simple objects. And again, so simple object just means that there is no sub level to those objects. So again, as I just said, they do not contain any other object. And then you have objects like tables and indexes and materialized views. Those are again, those are compound objects, and basically the reason why they're compound objects is because they have sub-level objects that's what they mean. So with tables, obviously you have rows, and the same thing with indexes. You also have columns, and then those columns have rows. So again, the same thing with materialized views. So you can find a number of examples of compound and also simple objects throughout throughout the Oracle software. So in terms of the Oracle log process, so basically, as I've said already, the log process ensures that the server process has access to the database object. Basically what it does is it depends on which mode you're in. So so if you are in basically when you have that lock process on an when your server process is able to get a lock on an object, basically in terms of the office for the lock process. What that means is that other server processes will still have access to that database object for reading. The only thing that they will not be able to do is make a modification to that database object, because that's the access right that you've been given. So the lock process just allows for you to have just to claim some sort of ownership over that database object for that period of time. But other processes will still be able to view the data that's inside of that database object. So and again, it depends on which lock mode you're in. Again, so I'm gonna cover lock mode. It's just down the page, so I'm gonna get to that in a minute. So basically, in terms of the log process, like some of the activities the operations that are associated with the log process are just again just inserts, upsets, and delete, and also some DDL. But basically, so when I say inserts, upsets, and delete, what I'm referring to, of course, is just operations that actually take quite a while to be performed. So when you perform a DML statement, basically what you have to do afterwards is typically you have to commit that statement, and so that's the difference between a lock and a latch. A latch is more for a DDL statement. That's where you have an implicit commit. I'm gonna get into what the latch is, and into greater details. But basically, in terms of the lock itself, it's just it takes it takes it allows for you to hold on to the access rights for a database object, not the, to, not the access and the change rights for a particular database object. But basically, other server clusters also have the same access, but they just can't make any changes to the database object yet. So, and again, so you can maintain your lock on a database object for a long period of time. You can be minutes or it can be hours. And again, that's gonna be what I'm gonna just demonstrate in my short demo, basically how to resolve having to deal with a user who has a lock on an object for an extended period of time. And then again, so locks and latches, they are completely different processes. Basically, they have fundamentally they have the same function, but basically in terms of how long you're able to claim access right and what the other subclasses are able to do, that's what makes them completely different. Locks, you can have a lock. You can have access rights to a database object for a certain period of time, but you can't do that with a latch. And then other sessions can have viewing rights to the database objects raw data, but with latches, basically you're in complete exclusivity in terms of just reading for the raw data. So the different modes inside of Oracle software for locks basically are exclusive, sub-exclusive, shared, sub-exclusive, shared, sub-shared, and null. So basically, again, you only have two types of object types inside of Oracle. You have simple objects and you have compound objects. And basically, and what you have is these lock modes are actually only basically associate themselves with a particular type of object. So basically, simple objects. Again, these are just some examples that I mentioned earlier. The buffer cache, the redo log buffer, they can only be in the exclusive mode, the null mode, and the shared mode. And basically, the exclusive mode is what I just described. So basically, you have exclusivity rights over the database object. You can make basically only you can modify on that database object, and basically you just have to commit before other server classes can then access the same database object. And then you have the null lock mode. So basically, the null lock mode is just a I think I should have. Yeah, I definitely have that on the next slide. So basically, you just have, okay, in terms of the simple object types, you have the exclusive, you have null and the shared modes, and again, so they're associated with the buffer cache and the redo log buffer, and basically another example of a simple object is the library cache. And then also you have compound objects, and these objects are basically also associated with different set of lock modes, and they are basically just sub-exclusive, sub-shared, and let me make sure I have this right. Sub-exclusive, shared, sub-exclusive, yeah, shared, sub-exclusive, sub-shared, and sub-exclusive. I'm gonna cover exactly what these different lock modes are in this one in an upcoming slide. So in terms of exclusive, I've just covered it. You just have if you have a exclusivity rights over a particular database object, and basically you do not allow for any other server process to make any changes on behalf of the user on that database object. And then basically a null log mode is basically what it does is it is attached to an object that's cached in memory, and then if that object is happens to be modified or any changes is takes place to that object, what happens is that that object is actually just invalidated, and basically that means that again you probably have to recreate that object. Basically eventually, and that's the only way you'll be able to access that object once again. So it's just to ensure that that the object has is structured the same, and basically just that the internals are not have not changed. So that's just that's the null lock mode on the database object. And then you again. So basically, this is these and the one mode that I just missed here is the shared lock mode. What this basically means is that certain processes are all able to view all able to view the raw data inside the database object, but they cannot make any changes. So it's again just to make sure that I have all those lock modes covered again. So you have exclusive, you have shared, and you have null. And then the lock modes for compound objects, you have subshared. Basically, this is just the access to sub level objects. So again, the example that I gave you earlier was the rows that you have in the table or an index. So basically, and also, let me make sure I have this right. And basically, what this means is that so basically think of a select for update statement. But basically, what you're doing is you're claiming exclusivity rights to those rows inside a statement. And basically, and so because you've claimed that number one is those rows cannot be accessed by any other user. But then again, they are able to see that those roles exist, and basically they what happens is that that their session is going to stall if they're attempting to basically apply any other changes to that particular those particular roles. So you also have sub exclusive, and again, you just have exclusivity rights to a sub level object, those rows again. Actually, you know what? The first one I described was the sub exclusive. So yeah, the sub exclusive is you have exclusivity right. The sub shared is you're able to share like access to those roles with different with other sessions. And again, I will give you the select for example. So and again, so with sub exclusive, on those roles, you are the only user who has who can make any modifications at any time, at any point in time. While you have those while the lock process is still answering to your server process. And then you have a shared sub exclusive. So basically, sub shared exclusive is basically it's just again it sounds very complicated, but again think of again you have access to a particular you have access to an object. That's number one. Again, all the different sub processes have access to that this object. But basically, yeah, the exclusive part comes in when basically with who is able to implement any change. So again, what I'm trying to say here is that basically the difference between uh, a simple object or a compound object and the different modes is, for example, with a compound object you would have a work clause where basically you're actually specifying which rows, and that's the reason why these are actually referred to as compound objects, because when rows are sub-level objects, and you can claim different rights, exclusive rights or the shared rights or the shared source exclusive. Shared source exclusive. And then with the lock mode, you cannot. There's no work loss. So basically, you just know that architecturally, that 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 for example, that object, if it's a buffer cache or a read log buffer, that basically contains is a database block. That's the difference between the compound object and a simple object in different mode types. And in terms of an example of locks in Oracle, you have transaction locks, you have row level locks, you have database buffer locks, you have data definition locks, and basically DDL again DDL the accurate DDL actually refers to data definition language, but again, the data definition lock is just it's basically again it's exclusivity rights that basically that ensures that that the table structure does not change while you're using it. So again, so that it sounds it sounds like the DDL that you may be familiar with with a different with the create, the alter, and the drop statements. Again, so this sort of ties in with that concept where basically table structure cannot be modified while you have DDL lock, that definition lock. And also you have a library cache lock. Basically, this is just a lock on a hash code. So what I'm trying to a library cache lock is basically what a library cache is. It's a memory area for your compiled and parsed SQL statements. So basically, and those statements have hash code basically associated with them. So when I say library cache log, what I'm trying to say is that some server processes cannot given access to those hash code for to service user requests. So that's what library cache log is. And then in terms of logs inside of Oracle software, basically they actually happen at the database block level. There is no log manager. Basically that's actually a good thing for Oracle, because typically when you have a log manager, basically that's responsible for just allocating different resources. They are not. They are not able to do it efficiently. So you basically just think of having a massive environment with on large databases on numerous tables. That means that you also have a large number of rows. But basically, that means if you were to have a log manager configured for that environment, that means that log manager would be responsible for basically the different memories of different resources, and whatever those objects need resources, memory space, just reallocation of different material. That's what the block module will be responsible for. But if you have, because the way that Oracle is configured, the environment, basically everything is at the database block level, and then the logs actually, the different logs that I've just gone over, they all occur at the database block level. So this is an example of a these are examples of simple and compound object locks. So basically, when I'm referring to simple objects, I'm referring to these database objects: the library cache, the dictionary cache, the database buffer cache, the video log buffer cache. So these are where you will find a simple object locks. Basically, you just have a lock on that database block. Again, so to just be more to sort of assign a name to the simple blocks, just an encompassment for these objects. Again, these are just memory structures. You're already familiar with the term. And also in terms of compound object locks, you have basically this is just an example of a database block. So when I say you have a compound object lock, what I'm referring to is the rows that are basically inside that block. So basically, with the way that transaction will be inside of a block is from the bottom up. So what that means is that if you have a compound object lock, you would have a session or subclass just claiming whichever right over one of the rows. So that's just the difference between what a simple object lock looks like and what a compound object lock looks like, block looks like. And so what I'm going to do now is I'm actually going to take you through, not yet, okay. Basically, I'm going to, these are the, in terms of session management, basically what you have to do is you have to basically just monitor the different log events inside of Oracle, right? So these are just some of the data dictionary views that you can look into to get that information on the different sessions, which sessions are basically responsible for for blocking other sessions, and basically also just how long a and also just which actually the session ID that's again so basically you're able to view the different logs that are taking place inside of Oracle with these data dictionary views, and basically you will be, let me make sure I just okay, so you are just able to basically just again I'm gonna demo an example pretty soon. So again, the reason why I have to say is basically I'm gonna use a set of columns, and basically I would like you to basically as I'm going to the example, you can also just come up with your own set of columns to monitor the different the access for the different sections to the database objects. So the DBA logs, basically what it does is it checks all the session IDs, and it also shows you basically which sessions have the logs, and the other session, how and which other sessions actually have are being affected by that log. And basically these are just the steps to have access to that information. You just have to be logging as 6DBA. And again, so this is the dictionary. So it's and the DBA, that's prefix just tells you that that's the privilege level that you have to be in. You have to have the 6DBA privilege to be able to view this information. So then you issue a describe on database that describe DB underscore logs, and then these are just the column that I chose to provide for my information, the session ID, and the blocking others. And again, I'm just gonna be downloading in just in a little bit. And then you have the DBA DML logs. These are used for for the anytime you see DML. I mean, not anytime, but basically it's very obvious, right? So DML is just for inserts, updates, and deletes. So these are just the different blocks that are taking place inside of Oracle. And again, so typically what would happen is that with DML locks, they're slow because once you issue a DML statement, you have to also run a permit to be able to basically just have that information be basically just submitted to the it's been basically when you issue a DML statement, what happens is that your request is submitted and it takes place, but for that to be infused into memory, into the to be cached to memory, basically you just have to issue a commit statement for the database blocks to be able to store that change that you have issued, that you have applied. So you have basically again you're logging as a DBA, then you just issue the describe on that on this that dictionary view. Let me make sure I have this right. Yeah. So again, this should say DBA, not DBM. So I'm thinking of packages here. So again, this is just I'm two steps ahead of myself, but this should be DBA. And again, you just issue a select session ID, blocking others, name. This is just the object name. That's being that's the object name for the name of the objects that's being that's on which the contention is taking place, and also the owner of that object. And then basically you're pointing that DBA DML logs. And then you have a DBA DDL logs. Basically, this is just for, and it's very obvious. You have DDL, so it's referring to the alter, the drop, and the create logs. And basically, what it can show is that the logs is placed on these on an object with these a DDL log is placed on an object to just ensure that there is no change, there is a modification made to the database, the structure of that database object. And also in terms of the DDL logs, just they're fast, and also again they're fast, and the reason why they're fast is because there is an implicit commit. So DML, you have to explicitly just write out a commit statement when you after you issuing your query, and with DDL you do not. It's implied that you're committing that you're committing that change that you're applying to the database object. And then you also have DBA blockers. Basically, what it shows you is basically the sessions that are responsible for blocking access to a database object. And again, so this is just how you would basically just look at that information. You would just describe DBA blockers and then select star from DBA blockers. And I think this is the only table. I think they only have like one column, so you can actually that's the reason why you start here. It's just I think the column is the blocking session column. I'm gonna show you guys in this short bit. So now I'm gonna go into the example. So I really want to. So I'm gonna have. Make sure I have these right. So I want to use 3 accounts. to do this, I'm gonna use the let me try this right. No. I'm gonna use a sys user account. I'm also gonna use the OE. I'm gonna use two sys user account. I'm gonna use the OE user account. So basically, I'm already logged in. So show user, and I'm using sys on this one. Let me show user on this one. And I'm using sys here, and then show user, and I'm using sys. So what I'm gonna do is, I believe it's on this one that I can connect with OE. Or let me see. Connect OE. That's not it. Connect OE. There you go. Let me try this one. Connect OE. You know what I'm thinking is, okay, so let me do this. So I'm gonna be, this is gonna be my DBA. I'm gonna be logged in as sysdba here, and then here I'm gonna be logged in as yeah. So just sysdba. So let me connect to sysdba here, and then my OE account. So let me do this with the OE. So I'm gonna be performing an update statement on one of my OE on the rows for one of my database objects. So what I'm gonna do is I want to describe the OE. I need to know what my tables are for OE. So select table, and from user underscore tables. So these are the tables that I have. And again, so one of the things that I have that I enable here is set timing on. To just what this does is it gives you an elapsed time. So like at the end of every statement that you commit, or that you commit no issue. So what I'm gonna do now is I'm gonna go into the orders. As you guys can see, the orders table. So let me do this. Describe orders. So that's my these are the columns inside of the orders table. So let me do this. What I'll do is I'm logging this is okay. Let me just remind myself. Okay. So what I'm gonna do is I'm gonna do an update statement, right? So I already know what the structure is. I'm gonna do an update statement on my orders table. But what I'm not going to be updating. So what I'm gonna do is I'm gonna update my let me see what I want to go for. My order total. Set order underscore total is equal to 150, right? Before, yeah, is equal to 150. What? So which? Let me do this. Select order total from orders where order total is less than or equal to 150. No, we'll select it. So let me run that code again to let's try 200. Okay. Okay. So basically, these are the different. I have 200 for these different order total as a value for these order total columns, right? So what I'll do is I'm gonna go back to the update statement that I was working on earlier. So what I'm gonna do is I'm gonna change the column values for these for the order total column. So set order underscore total is equal to let's say I'm gonna put 150, or order underscore total is 200. So what happened here is that basically 5 rows were updated, right? But the thing is, because I'm using a DML statement, the update or the change that I've applied has actually not been committed yet, and that means that it's not yet stored in memory inside the database inside the database block for the orders table object. What I'm gonna do is I am going to issue that same update statement, and then I'm going to show you not contention, but a log and a wait event for on the rows that I'm applying these changes to. Set order total is equal to, let's say, 160, or order total is equals to 200. Update set. So as you guys can see, this one actually is stalled because this one has this session has exclusivity rights on the order total on the rows for the order total column, right? So this one is not going to go anywhere. It's going to stay this way for basically until I commit this statement, or I roll back this statement, or if I'm a DBA, what I can also do is I can also just kill that session, the session that's basically responsible for basically the log process, and for not just giving rights, access rights to other sessions. What I'm gonna do is I'm gonna just go bonkers on this one, and I'm gonna kill this session. So let me do this. I need to figure out, first of all, to kill a session, you need to figure out what its SID is for that session. You also need to figure out what the serial number is, this SID number and the serial number is for that session. So what I'm gonna do is select what am I doing? Select. So as you can see, I have the SID here, and I have a serial number here. What I need to find out now is which there you go, blocking session and blocking instance. So let me do this. Serial number, SID, blocking underscore session, and let me see what else I can find. Blocking session. I need to also find You know what? On second thought, this should be enough. Let me see if I can get this from the dollar session. So, if you look at what I have here, right? So, this session is session number 22. And the blocking session is session number 145. So, what that means is that session number 145, this one is obviously the one that's blocking session number 22 from you know what? Let me try this right. Yeah, so session 22 is actually blocking session number 145. So 22 is here and then 145 is here. So what I would do is, or the easiest way to do this is to just select SID from the session. Yeah, I think I'm going to select SID from. Dang it. Okay. I don't have my. I'm using OE obviously, so I should not be able to. Yeah. But anyways, so basically, I have this is 22 and this is 145. So what I'm gonna do now is I have my serial number, right? So my session 22 has a number of 1602. So what I'm gonna do is I'm gonna kill this session. So let me issue this statement. Select alter system kill session, and then this is the text. This is syntax for the syntax to kill session is this. Let me sure I can minimize this enough. Kill session. Session number 22. Serial ID. Serial number is 1602. There you go. Close it. And the session has been killed. Or did I kill the right session? So let me make sure I this right. Okay, I take that back. So 145 is the blocking session. So this is 22 and this is 145. So 145 is actually the one that's responsible for blocking this session. So what I should have done is I should have issued auto system, but I should have, yes, again. So you just have to figure out the thing is Oko hasn't, it's not clear enough. Or basically, if you look at block session, you would figure it's the session being blocked, but actually it's the session that's responsible for the block on that other subject. So that's what the blocking session means. So let me do this. 2484. There you go. So what happened here is that I killed this session, right? Let me do this. Select. Let me just do a random select statement, right? Update. So I'm not connected. I'm no longer connected on this session, right? Because the session has been killed. So when this session was killed, this session basically was immediately committed. But what I could have also done is I could have just also roll back this statement. So let me put another example. So I showed you one example just how to kill a session entirely. Let me do this. I'm gonna connect this E again, and I'm gonna show you how to basically just roll back that statement. So no, yeah. So if you were to have a contention again, and basically on this session, what I've done is this is DML, but I haven't committed it yet. So if I was to roll back, so basically this DML statement was committed. So what I can also do is you can roll back you basically you can roll back an apply change that's not yet committed, or you can what you can also do is you can just what you can also do is you can commit it commit. So this one was committed, and because these are the same queries, zeros were updated. So basically, that's just how it works with Orgo. You when you're dealing with a DML lock, basically you can basically just sort of you can either kill a session, or you can basically roll back, or you can commit that change. What I'm also gonna do now is this is just a so these are different queries that you can use, different that dictionary you can use to get different types of information. So this is how you use these views. So describe the DBA underscore locks. Select what I have here. Select session ID. Let me give you an example of this. So it's been committed. I'm going to do this again. Order 160. Okay. Update. Set. Again, this is just again I've already given you the different approaches that you can run to resolve this issue of the DBA, and I'm just gonna give you just more information on the other sessions that are basically just going through contention right now. So select underscore ID, blocking underscore session, or blocking artists. I mean, basically it's just what these columns are. So blocking artists. Let me also do this lock type, and also mode underscore held. And again, you can basically just modify, change these columns as you choose, as you like, and you just have to be able to have an accurate reading of what sessions are involved in this block from DBA underscore locks. So basically, this is what you have here. You have basically 145 as the blocking session. So the column, again, if you look at the column reading, so the session ID, blocking address, log type, and a more held. So session ID is 145, and obviously 145 is the one that's responsible for blocking others. And then log type is the transaction log type, and this is just the mode held. It's the exclusive mode. So you can use the DBA logs to find out which session is responsible for the blocking. Or you can also issue you can also look into the DBA DML logs. So what I'm gonna do here is I'm gonna issue a select session underscore ID, blocking others name, and again, name is just the object name. Owner is the user, database user owns that object from DBA underscore DML underscore logs. So basically, here you just have a session ID. Um, okay. So basically, if so if you remember what I just went over, right? So this is an example of a transaction out. So basically, it's showing here as a not blocking because this is not DML log that we dealing with a transaction log. So, but this is the name of the object that's being obviously is this object or this table that's being held up in contention in the contention, and this is the owner of that object. And also, so you can figure out what the DBA blocks are. This pre the session that in contention. You can figure out basically, you know, which again, just which objects being you know so playing a role inside of that lock contention. You can also figure out basically it would be the same thing with if you were to do a DDL a DB underscore DDL reading. So let me just do that for you. DDL underscore locks. So again, so what you be looking at is the same as basically the DBA, DBA, DML are the same exact have the same exact the same exact table structure. So basically you be just calling, if I was to issue this select statement with DDL basically, and one of the things that I looked over was basically this one, DML has a blocking nodes and DDL does not. So let me do this. Let me get rid of blocking nodes. Let me owner name, session ID, and that should be good enough. Okay. Basically, again, one of the things that I'm not gonna do is I'm not really the best when it comes to setting up line size. I usually just try to avoid it because I'm not sure what the heck goes on when you issue those set line sizes, set page size and whatnot. But basically, this is what. Let me see if I can try for this one. Hopefully I get lucky. Yeah, I wasn't lucky. So again, it's the same. It has the same look. So again, that's why I just avoid. I try to avoid having to set the line stuff because I'm horrible at it. So let me do this. So I've just given you. So I just went over the DBA, DBA locks. The last table that you can also review is the DBA underscore lockers. Well, basically this is just only showing you the holding session. So select stuff from DBA underscore blockers. So basically what this is telling me is that this is the corporate. This is a session that's basically you know, responsible for the lock. So again, this is just a shortcut way of finding that out. So let me move forward. So what I'm gonna do is, again, I've already given you basically I've already shown you how to find out which session is responsible for that a lock, and basically what type of lock it is, the mode, on which object that lock has been placed on. I'm gonna stop right here, and then next time when I pick up, I'm gonna go over basically just to, you know, what a block is, and I'm also gonna introduce you to also just like some of the other features that you would find in a block, and basically just how I'm gonna go into how a block is you know, works or functions inside of Oracle software. Thank you so much for watching.